Welcome, everyone. We are going to talk about in this video a way that we can walk you through how to evaluate site suitability for a tiny home community using a multi-criteria evaluation process in ArcGIS Pro. Now, in order to do this, we are going to be looking at, in this example anyway, vacant lots and evaluating their proximity to key facilities like bus stops, libraries, and schools, ensuring that the selected parcels aren't adjacent to agriculture or industrial zones. This is just the foundation. This is an example of how you can do these different processes, prepare your data, compile your data, and run through this process of site suitability. Now, that doesn't mean that these pieces of information that we are using today are everything that you need. You will probably do at least 5 or 10 different pieces of data for different types of criteria. So really is whatever you feel is important, whatever your research has shown you is important for site suitability. That is the route that you'll be going. But just for the example today, keep things manageable. We're just going to be using 3 pieces of data here. So hopefully the screen is showing just fine here, and we have ArcGIS pulled up. When I have this project pulled up, it's showing our catalog. This is the file management program here. If you ever get to this and are like, oh, I need a map, we just simply go over to Insert and click on a new map. The map loads in, and this is what you should be familiar with seeing, ArcGIS for United States here. So we're going to go ahead and add in our data. Now, the data that I use is located in a geodatabase that I created. I like to keep my data in one folder in one geodatabase. Whenever I get new data for, let's say for Greensboro, I deposit it into the Greensboro database. Now it comes in here. This is what you'll see when you get shape files and so on, that you'll have the different information in there. But what I do is in catalog, I copy these over, and I can show you very quickly how to do that. So when you're going through and you have, say, a parcel polygon layer that you want to copy over, you can right click on it and we go to export and then feature class to geodatabase. And from here, loads that in, and then you can specify what it does. Now, because this isn't a project, it opens up and creates its own geodatabase for that. So what I would do is, in this case, go in and go to my Greensboro geodatabase folder and put it in there. So then it selects that, and then I would hit run, and it would copy that data over and ultimately then copies it into the folder here. So that's in catalog. You can do that for all of your data. Keep it all nice and neat. Data organization is a must when dealing with GIS. So how do we get it in? So then we go up to here, we're just under our map tab, and we're going to go to add data. And navigate to our Greensboro geodatabase. And then we're going to load in the data that we want. So for this example, we're going to do bus stops, libraries, and schools. So I'm going to select bus stops. I'm going to select libraries and schools. I'm also going to grab our parcels layer because that has our zoning data. And then I'm going to grab our state and county boundary layer. So those are the 5 layers that we're going to be using for this example. When you are actually doing this process yourself, you're going to have probably much more data, more things to go. But just to keep things simple for this walkthrough, I'm going to show you a process that you can then apply to your own criteria. So we hit OK to add that all in, and it loads the data in. Now what you'll see is we can see the parcels layers over here, but it's not showing up in Guilford County. So the reason for that is that this drawing order is how it also displays. So if we want to see the parcel layer, we got to click on the county boundary, drag that down below, and now it pops up there. So we don't necessarily need for this process all the counties in North Carolina. For that matter, we don't need all these extra little data points that are outside of Greensboro. So the first thing we're going to do is kind of start to trim down our data so that we're only working with what we need. and that helps free up some memory on our computer as well. So to do this, what we're going to do is we're going to take and just select Guilford County as the county boundary here. So I have it selected. I'm going to click on our select by attribute, should pull it up. Hopefully in the recording, it is showing you the box window here that has the select by attribute. And it's going to automatically populate the selected layer, which is our county boundary layer. It's a new selection type, and this is where we got to find out what field are we using. This one's pretty straightforward. We know that we want to use the county layer, but to double check that, what we can do is we can right click on the layer and open up the attribute table. And then in the attribute table, we can take a look through all the different columns here to find out what data is stored for these layers. So we can here see that county stores all the names of the counties. So that definitely is the layer field that we're going for. So we're going to then go here, it's alphabetical, and select Guilford and hit OK. And now you can see that we have selected Guilford County. Next thing we're going to do is we just want to get Guilford County by itself. So we're going to do a temporary file. And to do that, we are going to go to right click on the layer, go to selection, and make layer from selected feature. So that now separates it here in this new layer that we did, that is the selection layer. I'm just going to rename that Guilford County. Okay, so now that we've renamed it Guilford County, we can always clear our selection, make sure nothing gets mixed up there. I'm going to turn off the rest of the counties because we don't need it, and rearrange our drawing order so that the county is below the parcel so we can see the parcels. Zooming in, we can see the parcels set back. The county's county boundary is behind it. You can see that most of these line up pretty well here. So things are looking pretty good. Our projections are aligning. Our data is looking good. So the next thing we want to do, we could do a couple things. We could trim down, clip all our little bus stops and public library and school points to Guilford County, but we know that we also don't want to run this for all of Guilford County. We just want Greensboro. So what we're going to do first is take a look at our polygon layer for parcels. So we're going to take a look at the attribute table and look and see what's stored in here. So when we open up the attribute table for it and take a look, we can see quite a bit of information here. So these parcels are the official recording of everything about a parcel in Guilford County. That includes the size, the acreage, different numbers and labels that are for that, its land value, the full title of its ledger entry, mailing address, mailing prefix, the mailing city, which doesn't help us because that's where mail for the owner gets sent to. So we're going to keep looking. It keeps on coming through. It even will tell you the name of the person who owns the property. So we keep on scrolling over. Eventually we get to S City, and that is the location of the parcel where it is actually physically located. So that's going to be the field that we're looking for, is S City. So when we do our select by attribute for the Guilford County parcel poly layer, we're going to come down and find that S City layer. And we're going to make it equal to Greensboro. You will see that there are some other ones here, but these are like shared properties. There's only like one or two points in each one. It's good to double check it to see, but we're just going to take Greensboro for this. Hit apply, and you can see it's selected all of the parcels that are listed as being Greensboro City. And what we roughly see is that shape of Greensboro's city limit. Let me hit OK here. So we have that. Now what we're going to do is we want to save these because this is going to be an important layer for us. So rather than right clicking and going to selection and make layer from selected feature, we are instead going to go down to data and export feature. So it's going to trigger here for use the selected record. So the 100,000 parcels that are in Greensboro is what we're going to do. And then it gives our output feature class. I find editing the name here can be a little bit difficult because it loads the entire pathing for where the file is located. So you can always rename it afterward, but otherwise, what we're going to do is rename this GSO parcels. And always make sure you use an underscore in here just to ensure that there are no errors when it processes, because this program does run on Python. Spaces mean certain things. Underscores mean spaces for what we're used to. So use an underscore whenever you mean a space in most titles. And we hit OK, and it's going to export those features. So it accomplishes the same thing as making a layer from the selected feature. And if I turn off the parcels, you can see it's now just the Greensboro parcels. So it accomplishes the same thing as make layer from selected feature, but the difference between the two is when you make a layer from a selected feature, what it does is it creates a temporary file that is saved only to the project. But when you export the data as a feature class, it saves it to the geodatabase as a feature class, meaning you can transfer it geodatabase to geodatabase. And it's not restricted, can't be lost. So I haven't saved the project yet. So if something happened and the project closed, I would lose any of those layers that I made from a feature class that are unsaved. By exporting to a feature class, that data is safe. It has saved it as its own layer, its own file, and is simply displaying that data now. So it's really important when you have something that you're working with that's not a temporary file, that it's okay if it goes away. It's just some stuff that you're doing as you're playing around with your data. Use the make layer from selected feature, but when you are set and you have the data and you want to keep it that way, use the export feature class. So we have our Greensboro parcels, we have our Guilford County border, and then we have our point layers for schools, libraries, and bus stops. So it's at this point then that we can start to clip down our different point layers into the Greensboro city limits, essentially. Since what we're looking for is a half-mile buffer around each of these points, the first thing I'm going to do is make a buffer around Greensboro parcels out to a half-mile. That way, any of these point layers that might be out there outside the city limits will still be captured. So those parcels that fall within that half-mile radius, that even though the point might not fall within city limits, the parcels themselves can still be tracked that way. So in order to do that, we need to do some geoprocessing. So I have the parcels layer selected. We're going to go over to our analysis tab, to our tools. That brings up our geoprocessing menu. So what we're going to do is a buffer. So we're going to type in buffer, and it pulls it up. So the first one that we want is buffer analysis tool. So the input feature that we're going to do is our GSO parcels. And the distance that we want to do is a half-mile, 0.5. And under units, we're going to go to US survey miles. Now, for this one, what we want to do is, because this is just a single polygon, essentially, that we want, it has no data that we need. We're going to give a dissolve type on here. So we're going to dissolve all output features into a single feature. All that does is keeps the file size small. It gets rid of all those extra parcel data things on there that we don't need to worry about. So it's a little bit more intensive to run it as it goes through and deletes all of that. But in the long run, it will lead to slightly faster processing times for our computer when we're using that to, say, clip features down and so on. So I'll go ahead and run that one. Now, there are two different methods here. I just left this as the default planner. You could also do geodesic. So what planner does is it just does a radius half-mile, and it rounds the corners. Geodesic, as it says, shape preserving, would keep the actual geometry here of the different things. For what we're doing, it could make a difference, but probably not. So with planar, we get nice round edges. Oftentimes a smoother look rather than pointy, jagged edges. So that's why I typically will go with planar unless it's something specific that we want to keep the exact shape for. Okay. So we have all of that we're looking at here. We have our parcel buffer run, and we are looking pretty good there. So the next thing we're going to do is we're going to clip our 3 different layers to our GSO parcel buffer. So in our geoprocessing menu here, we're going to type in clip, and we have clip analysis tool. And we're going to put our input feature, and this is the feature that we want to clip down. So the first one is going to be public schools. Our clip feature is what we're clipping it against, which is the GSO parcels buffer. And then it's going to automatically populate what the clip is here. So what I'm going to do, I'm going to rename this, instead of public schools clip, I'm going to rename it public schools GSO, so I don't get that confused and I know exactly what that layer is for. And then I hit run. And then I can turn off the public schools. You can see they're gone from the rest of the state, but they still remain here within the boundary of Greensboro within a half mile. So you can see that half-mile buffer did end up catching, where was that? Up here. Catching some of those schools that were outside of that didn't fall within the boundary of our parcels, but fell within the boundary of some parcels. So could be important, may not be important, but it's there. So that's what we have. Okay. So the next thing we're going to do is do our next layer. So to clear this, you can either go through and rename everything, but I just like to hit back and come back in. That resets the tool. So next is libraries. Clip feature is our parcels buffer. It automatically names it here. We're going to change this one from clip to GSO and run that one. And that's in here now. So public libraries. So check. Yep, so that clipped our public libraries down. All right, next thing we're going to do, last one, is our bus stops. And we're going to do clip parcel buffer again. Bus stop clip, we're going to do bus stop GSO. And click run. Okay. So now we shouldn't have any data outside of our little buffer here. Shouldn't have anything floating around, which we don't. So that means the process worked exactly as it was supposed to. Cool. So we have everything clipped down to here within our Greensboro city limits. All right, so I'm gonna move the parcel buffer below, turn the parcels back on so we can see the parcels. So now what? What's the next step? So we have gotten our data clipped down so it can move much faster. We're not having data trying to load all over a large area such as the entire map. So the next thing we need to do is identify, in this example, we're going to identify and rank vacant lots based on their proximity to bus stops, public libraries, and public schools. But we don't want these vacant lots adjacent to industrial or agricultural zone sites. So to do that, we're going to take a look at our parcels layer again, double check the attribute table and find where does it talk about zoning in this table. So where we can find this is going to be in the parcel use description category, where it talks about townhomes, condos, residential. So this has all of that zoning data here. So you can see IND is industrial, residential, utility, so on. For simplicity, we're just going to take industrial and agricultural. So what we're going to do is go back to our map tab, and we're going to do a select by attribute. Now we're going to do two things with this. We're going to select our use description and set that equal to agriculture and horticulture. Then we're going to add a clause because we want to select both agriculture and industrial. And we're going to set this one to same thing, our use description, and to industrial. Now, if we hit apply here, what you'll notice is nothing happens. So this and doesn't mean that we're looking for both of these types of parcels. It's looking for a parcel that falls under agriculture and horticulture, as well as being zoned as industrial, which that doesn't exist. It only has one type of zoning. So we change this to or, and it means it's going to grab all parcels that are agricultural or horticulture, or any parcels that are industrial. So it's combining that, and then when we do that, we can see it's grabbed. Now, if you want to double check, make sure we want to see what the agriculture is minus the industrial, we can do that. You can see there's our agricultural sites. So yeah, it did. There's a lot of industrial all through the center part of Greensboro. So we'll add that back on so that we can grab all of those at the same time. Change that to or and apply, and you see, all right, so now we have the agricultural sites as well as our industrial sites. So I'm gonna hit OK here, and this is a temporary file, just something that we temporarily need. So I am going to just make a layer from the selected feature on this one, and we're going to name this GSO bad parcels. We don't want them. You can be more creative in your naming, but we'll just go with what it is. Okay, clear that out. So I can turn off our parcel layer, and we can see we have those parcels here that are industrial and agriculture. You can double check that by coming in, just clicking on one. It brings up some little quick facts, querying the results. Because it's taking a moment for it to do that. There it goes. And then you can scroll down and see power use description. It's industrial. You can also double check its attribute table that it did do what it was supposed to, and go on over to that power use description. Power use description. There it is. And then look through this list here, look through the 2000 parcels or so that it select that it brought in, and double check that they are what they're supposed to be. So we should be good there. All right. So now that we have that, now what? So the next thing we're going to do is we're going to turn our parcels back on, and we're going to come back to our GSO parcels layer. So what we want are our vacant lots that are not adjacent to our bad parcels. So we're going to do first a select by attribute. And we're going to clear these out. So we instead this time we want our vacant lots. I'll hit apply. So there's all our vacant lots in Greensboro. It's a lot, isn't it? See, it's a pretty decent distribution across the city. Larger collection, it seems, here on the east side of Greensboro. So now that we have this selection, we're just going to hit OK. We're not going to do anything with that just yet because we want to filter away any lots that are adjacent to our bad parcels. So to do that, we're going to go and do a select by location. So our input feature are parcels because it's already what's selected. What we want to do is change the relationship to boundary touches. So any of these parcels that are selected that touch with our selecting feature, which is our bad parcels, will be excluded. Now to do that, we change our selection type from new selection to remove from the current selection. So then when we do that, it was very quick there, but you could see that a couple parcels were removed from the selection. So now what we're left with are just our vacant lot parcels that are not adjacent to either industrial or agricultural sites. So for this one, then I'm going to go and I want to keep this layer. So we're going to do export feature. And we're going to rename this layer to potential tiny home lots because these are the layers that perhaps might, oops, put that back as parcel selected feature, and that goes down here. Goes in here. All right, and then I'm going to get rid of these spaces and put underscores there instead, just so that we don't have any issues when it comes to processing. And get rid of that trailing space. Okay. All right, so now we have our potential tiny home slots. All right, so we can turn off these other layers. So we just have the buffer layer, our point layers within Greensboro city limits, and our parcels. So you can see where they are. Some large parcels, bunch of smaller parcels. And then over here, you can see there's A&T's campus and that neighborhood right along here, right along Blueford, right over here. Blueford and Boyd, all these vacant lots in here the university is trying to buy up. Okay. So from here, what do? We want to find out what parcels are within a distance of our different features. So there are two ways that we can do that. We could create buffers around each of our selecting features and use that as a visual tool that can be very helpful. So there's going to be two steps. I'm going to show that step first, and I'm going to show a different way that we can do it. So same way you could do a buffer around each of these points and then do a clip where we grab the parcels that fall within those. But what we have is a layer here, and through just doing select by attribute, select by location, we can actually accomplish that in fewer steps. But in terms of visually displaying your data, the buffer rings can be very helpful for that. So for that, what we're going to do is we're just going to run some buffers here. Type back in and go buffer. And we're just going to put buffers, half-mile buffers, around each of our bus stops, our libraries, and our public schools. So there's always two different ways that you can do your data. One is, always keep in mind that you're making a map. So you want to have visual elements as well as statistic elements. So the statistics are what we're going to use to determine the best location. But visually, we also want to map that and have it make sense to our audience. So we're going to create these buffers because we can use the buffers then to display that data and paint the visual picture for anyone who's looking at this. So we just go ahead and create our buffers. So when we didn't do a dissolve, you can see it does individual rings around each buffer. So I don't really like that. So I'm going to remove that layer. And I'm going to run it this time doing a dissolve. So we'll run that one more time here, and that looks much better. So there's our bus stop buffers. And we're going to run buffers for our public library. Put the dissolve back on there. Half-mile radius. And run that one. Not that many public libraries. Okay. And then last one we're going to run is our schools. Half-mile radius. And we're going to put a dissolve on there. Okay, a few more schools. So altogether, the three of them, you can see them all there. It doesn't do to have them joined together because we want to rank our results. Now, with only three in here, it's going to probably give us likely a lot of results. And you can already start to see where we have lots of overlap, where our areas of, based on this site selection process, are going to pop up. So these darker parts of these circles, if there are any parcels in here, these will probably score higher because they're hitting in multiple aspects of our criteria. So we will actually do this through math and have tables that will show this information, as well as we can grab these parcels and show them visually as well. So what we're going to do here is we're going to come back to our parcels layer, our potential tiny home lots. And what I want to do is select the lots that fall within these buffers. Now I could do this two ways. We could do that the clip option. But what clip ends up doing is, let's say, like it might fall, this parcel here technically is within this one, but it clips it to the buffer boundary. So we would lose the definition of the parcel and it would cut it off and make kind of this weird little shape here. So I don't want that. So what we're going to do instead is a select by location. So it accomplishes the same thing. The relationship that we're going to do, we want to make sure that we're doing the same relationship in each of these ones. For this one, I want to go based on the center, or that the whole thing is within a distance. So our potential tiny home lots are within a distance of our bus stops. I'm using the actual layer, not the buffer layer for this, because we're doing the same thing as we had pre-buffer, doing that half-mile radius. I'm just going to bring it up in a new selection. And we'll hit apply so you can see where it starts to pull in where those bus stop, the parcels that are within those bus stops. So you can see if we had done a clip instead, it would have cut a lot of these parcels out. So some of these parcels, which, depends on what you're feeling. Does this parcel actually fall within truly a half-mile of a bus stop? And then there are other factors to consider as well. It's like if you're up here, the bus stop's down here, there's a lot, including getting past Market Street to come down here. Now, another disclaimer on the data that I have, I found a layer called bus stops, but I believe they were for only certain routes. So that's why we're seeing the bus stop layers being only in these areas coming down this way along, where are we? I think we're coming down like Gate City Boulevard and along this way, coming on through here and going out that way. So always double check your data and know exactly what your data is coming from. So this is going to return biased results because bus stops are one of the criteria that we're filtering by, and our bus stop data is only for certain sections of the city, not bus stops for the entire city as a whole. So that will change the results of the data based on what you find and use. So I hit OK here. What we're going to do is I just want a temporary layer. So I'm going to make a layer from the selected feature, and I'm going to name this one near bus stops. And I need to do underscores just to be safe. It will let you do spaces instead, but just to be safe, use underscores. Okay, so that's that one. Then we're going to do that again. We're doing our potential tiny home lots that are within a distance, this time of our public libraries, and that distance being a mile. So that's selected our locations within a half mile of public libraries. And again, we're going to create, make a layer from that selected feature. And then we're going to name this one here. And then clear selection, and then run this one last time, select by location. This time we're doing based on the schools. And kept all that data in there. Cool. All right, apply. So there's our parcels that fall within a half mile of schools. And again, you can see kind of pulling distance. I guess that falls within a half mile. So some of this could be a little mismatch in the projection on, like, our point is here and these half mile buffers are off a little bit on some of it. So that's just a probably mismatch in the projection. That's why it's showing like that, but that's okay. This is just to show you the process of how it works, but it's also good, always look through your data and double check everything. All right, so make layer from selected feature, section, make layer, and then this is our schools. Okay. So now we have our 3 layers here. I'm going to turn off our potential tiny home lots and clear our selection. I'm also going to turn off the bus stop buffer. I'm going to pull off the other little buffers. Cool. Okay. And now we don't need these points really visible anymore because we're just focusing on our parcels. So these parcels, what do? They don't look like anything here. So we can mess with that. We can play with it. We can see what that means and what that does. So what we want to do is we want to rank this. Now this is where it's really cool that we have, when you make a layer from selected feature, it's just copying it over and basically filtering the selection. So when I pull up the attribute table, that it's showing this like this with the attribute table. And what we want to do is we want to add a field. So when we add a field down here, we're going to name this. This is our tiny home lot, potential tiny home lots near schools. So we're going to name this our school, and it physically won't let you put a space here, so you have to use underscores. School score. Oh, it doesn't like that. Oh, because I had already created that. Okay, just a second here. Let me, so I'd already created these going through before. So what we are going to do is discard that. I'm going to go back and delete. So the cool thing about this is when we are doing that, what it does is it links it to the parent file. So even though these are all separate, they're still linked to this table. So anything that you add onto the tables for these shows up here. So that's why, and this is what it'll look like when we're done, is having our different scores here. So I'm going to edit and delete these so that I can show you how to add them in. Okay. And so when I deleted them there, this one had it. So if I pull up the attribute table here and go to the end, you can see it's also disappeared from that. So really cool how they're linked like that. So that when we go to our add field here, now it should let us do our school score. And I could go ahead and just add in our library score and our bus stop score. But I'm going to show that on each of these so that you can see that we added the school score and it'll show up when we start going into the other ones here. So I've added it in. We're going to close that and save. That was our school score. We're going to do libraries, go to our attribute table. So in this one now we can see the school score is in there. I'm going to add the field, and this is our library score. And then we're going to do it for our bus stops as well. You can see the school and library scores are already there. So this is going to be our bus stop score. Okay. All right, so I added it to these three. And again, just to show you, we'll pull up our potential tiny home attribute table. And you can see that it's here. Now, I'm going to double check that it didn't show up in the parcel. Though it might actually still be in the parcel layer because that's where we pulled it from. So that's why it's very careful. Yeah, you can see that these are still here. But this one has the total score. I didn't add that total score in yet. So I had already done that as I was testing the data before. So you can see the total score is there. But here, in this one, I was using churches instead of libraries. So anyway, so using our three for schools, libraries, and bus stops is what we're going to go for this example. So we have those in here, and then what we're going to do is we're going to go back into the attribute table, and it's important to have them separate like this for this reason, because we can come here and put our school score for each of these, and we can do calculate. So this is our potential tiny home lots near a school. I'm going to click on calculate, and it's going to say, okay, what do we want to do here? Our school score is equal to 1. So we want to give it 1 point if it shows up in this list. So it added 1 point to each of these. Now we're going to open up for our near library and do the same thing for our library score. And you can see where some of these have already overlapped, and we can already start to see that. So our library score is what we're going to do and calculate for this one. Same thing, library score equals 1. Cool. And then lastly, we're going to do that for our bus stop layer. We can start to see some of these parcels are, see what we're going to get. One here that's probably going to, at least based on this selection criteria, be a prime spot for us. So calculate bus stop score is 1. We hit OK. Okay, so that has added that in here. So now when we go to our potential tiny home lot, and look at this attribute table, we should also see that they've been populated in here. So what we're going to do now is add one more field. And what we want to do here is make this our total score field. We see that at the very end. And we want to calculate for this so that it adds up our school score plus our library score plus our bus stop score. So we're going to do calculate. Now this one is a little bit more difficult. It's not as intuitive. You'd say, okay, so I want to add up those 3 columns. Wouldn't I just do school score plus library score plus bus stop score, and that equals our total score, right? It does, but it doesn't. So if I were to do that, what ends up happening is we get an error that says some rows are set to null due to an error in the Python expression. So again, this runs off of Python. It doesn't like that. So even when we do have data that should come in, you'd think, right, this would be a 1, this should be a 0. It just, because there was a null, it returns as a null. So the way that we fix that is we write a little bit more of a complex code for this. And the cool thing about Python is ChatGPT is very good at it. So if ever you get hung up on code doing Python, anything like this for GIS, ArcGIS, ChatGPT is really good at troubleshooting and finding those errors for you. Because unless you have taken plenty of classes and become an expert at Python or coding, some sort of programming language, that's more than any of us care to get into right now. So the what we're going to use, I already have the code here, so I'm going to just copy it over and it will display here. So you should be able to just copy it in if you can see it. That's the extent of it there. So I'll just leave that up. You can pause the video and type it. Basically, what this expression is using a parenthesis, a 0, if, and then it's the layer bus stop score. It's the first one, is none, else is then choose the bus stop score. What that means is if a field is returning as none, null, then it should return as that score, which is 0. So if it doesn't have a score, return it as 0 is basically what this expression is saying. So that's what it's saying. That's what we're going to do. So when we run the code for this one, well, what we see now is showing up as zeros when there was nothing, and 1 when there's just 1. And if there's 2, it's showing as 2. Maximum score would be 3. So, okay, cool. We have this. What does that mean? We're going to turn off these little subset layers. And what we want to do is show our potential tiny home lots and show our ranking. So in order to do that, we're going to right click and go to symbology. And right now it's set up as single symbol. What we're going to do is we can do unique values. We can do graduated colors. So unique values will do that. But what it does is it sets to a certain field. So we want to make sure that we're choosing our total score field. And that will show our 3 different values here. So you can then change the color. Say, okay, what color do we want to use? I'm going to use just a neutral color that looks like nothing for our 0 because they're not important. Our score of 1 is not great, so I'm going to use a muted red color. The score of 2 is a little bit better. I use a muted yellow color. But the one we're really interested in is, our 3, which is our best fit. So I'm going to put that in a nice bright green so we can see that. So now what we can look through here and see where are our bright green parcels. And they are all down in here. So what this says is any of these parcels are within a half mile of a school, a library, and a bus stop. Meaning based on our selection criteria, these parcels are the most ideal locations for creating a tiny home lot. So there are other things that we can then factor this in, such as acreage. We can add other amenities to it, other criteria that further whittles down this selection so that maybe we are only left with 2 or 3 different places in Greensboro. Or we just have a bunch of places that we choose from and we choose the best fit that way. So it just depends on what we want. Do we want it in the heart of Greensboro? Do we want it on the outskirts? Do we want it within a certain distance or not within a half mile of, say, railroad tracks? That would greatly probably eliminate most of these sites being rail lines all along through here. So it just depends on what your criteria is, how you might further whittle this down. Now, those buffers that we made, showing them this way, now we can start to put these on top so we can see. You play with the symbologies on each of these. You can clean up the map. You can turn on, give it a backdrop instead of Guilford County, however you want to create that map so that it makes sense. You can do individual maps of just the different buffer zones and your selections. So instead of showing all of them, um, maybe we're only looking at our schools and turn on our schools. So these are all of our schools that are within the buffer. I'll turn off the GSO buffer so we can see that. So and then you can play with the symbology on each of these to make them more visible. So maybe these need to be bright green. We can see that. So contrasting colors, you can turn it into a map to have that. But here's the data this way. You have the attribute table that is going to support you that way. What else you can do? You can go to share and you can print or export your map. You can also set up scaled maps as well. So if we go to, you can just automatically just export a map and it's going to just take the extents that you have here. But otherwise you can kind of look through and come to a new layout under our insert tab and set up the size of paper that you want. So if you wanted to print these maps off on a 24 by 36, you have that option, 11 by 17. So let's say we wanted to take a map of this, have it as 11 by 17, so we can pull it out and do some trace over it. So we can set that up here with our layout, and we come up and do a map frame. We can just do extensive our map, and we can just drag and drop. This works very similar to layout like in AutoCAD, and these are viewports essentially. So there's that. You have options for putting in north arrow, whatever, a bunch of different types of north arrows you can choose from. Choose a fun one, put it in, place it where you want. Get that scale bar in here, load it, whatever makes sense, the one that you like. You can play with the size to affect, and it just automatically scales with that until you get something, a distance that you like. That way, you can also double click on it and edit it out that way as well. Set your units that way. So scale bar, north arrow, extents, and this is where you can also turn layers on and off, so you can mess with it that way. And then same thing here. Once you have your map set up like this, you can go and you can print your layout, export the layout, and so on. So that is how you can do it. What this does when you do export, you can set it as a vector PDF, and that would allow you to open the map up in, say, like Illustrator or AutoCAD, to be able to manipulate it that way. The other way is if you wanted to send this to AutoCAD to manipulate. Now, at this scale, that's kind of big, but let's say that you get down to a certain site selection and have different utilities and things like that, you start to load in, and I'm just pointing over here. Let's say this was your site. So you have all your data layers. This is what we want. You can use, it's under Analysis tab, Tools, the option for this is export to CAD. So this tool, you essentially load in all the layers that you want to include. So whatever those layers might be, you include it. And then this is where you name the file. So you can name the file whatever you want, PWG. When you click run, it'll send all these feature classes to AutoCAD for you. And you can open up the AutoCAD file then and run it that way. And now have all your information in AutoCAD so that you can start building your base map and printing it off that way. So two different ways that you can do that through your layout in here to get aerial maps and so on. You can also then export to AutoCAD or export to a vector PDF and be able to edit these maps that you make in GIS through Illustrator or in Photoshop. Clean them up, make them look nice. If you don't like working in ArcGIS for the symbology that's in here, you can take it into Illustrator and use the symbology there. So different ways that you can do that. I hope this was informative on how you can start to do that multi-criteria evaluation, site selection process, site suitability, all different names for the same thing. This is just one way of doing it. This is a way that we do it so that because we were focusing on particular parcels, there are other ways such as like a weighted overlay if you have rasters. If you weren't looking for like particular vector data locations like parcels, and if you were looking for areas such as locating on a specific site, let's say you had a topographic map that's raster layer and some other information, that's where a weighted overlay can be really helpful when you're positioning elements on site based on slope and soils and so on. That you can do a weighted overlay analysis to determine the best location for that feature to go there. But in this example, we really wanted to stay in vector data. It didn't have any raster data. So weighted overlay was not going to work. So the way that we do that is through using the attribute table and assigning values to each of these data points, and then combining a score that way to get our ranking system. So hopefully this was informative. Hope you enjoy it. Hope you find it useful, and I wish you luck on finding a spot for tiny homes in Greensboro.